So we now make progress to differentiation techniques. So let's go direct to the question. So the question one says, use the first principle to define the derivative of which of the following functions at x is equal to 4. So we have a f of x is equal to x squared plus 1, b f of x is equal to x minus 6, and c f of x is equal to x cubic plus 2. So for this one, let's just go direct to c. So our c is f of x is equal to x cubic plus 2, and at the point x is equal to 4. So I know that most of it you are thinking that since you have been given x is equal to 4, why there is x cubic you have to replace a 4. No, you first have to use the first principle you differentiate, then at last that's when you replace. So now let's move to the formula for the first principle. So the formula for the first principle is given by f prime of x is equal to, so f prime of x is this. In other words, you can say change in y over change in x. In other words, as you know, it is dy over dx, which is equal to limit as x approaches, or as h approaches 0, of f of x plus h minus f of x over h. So we're going to use this formula now to differentiate this function. So this simply means just the f of x plus h is just the same as what there is x in this function, you place x plus h. So let's replace x plus h on this function here. So limit as h approaches 0 of, or there is x cubic, you say x plus h cubic plus 2 minus f of x is this entire function. So what is f of x, we replace this entire function. What we have x cubic plus 2 over h, so which is equal to, so we now you have to expand this function. Expansion, you have eight of ways you can expand this, and if you want, you can go back to semester 1 where you can use what you can use you can use binomial expansion. So so the limit as h approaches 0, so if you expand this function, it should give you something like x cubic plus 3x squared h plus 3xh squared plus h squared. Then you're done with this, then plus this 2 here, so plus 2, then negative times x cubic, you're going to have negative x cubic, negative times 2 positive 2, negative 2 over h. So as you can see, you have e on top here, you have like them. So this one and this one cancels. Negative 2 positive 2 cancels. So as you remain with limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubic, not squared, this is h cubic, yeah, then over h. So from here you can see this function is factorizable, because if you put h here, this one will be undefined if you go back to the rules of limits. So you're going to have limit as h approaches 0, so you factorize h here, so h, so you're going to have 3x squared plus 3xh plus h squared over h. So as this h and this h cancels, then you're going to mean with limit as this h approaches 0 of 3x squared plus 3xh plus h squared. So this simply means just what there is h, you place with a 0. So if for all there is x in this function, h you push a 0. So 3x squared plus 3x 0 plus 0 squared. So this is 0, this is 0. So going to have 3x squared. So this one is just your f prime of x. Now recall that x is equal to 4. So you're going to have f prime of 4. So what is x you place with a 4? So you're going to have 3x plus 3 4 squared. So 4 squared is 16. So 3 times 16 gives you 48. As simple as that. So you can use the same principle to answer A and B. So for how are you going to answer? So what the x squared, you're going to just put x plus h, then plus 1, then minus f of x. F of x, you're going to replace this whole function so that you're going to see what will cancel it themselves out as it will just be a straightforward question. Then on x minus 6, what there is x, you place x plus h, then minus 6. Then on f of x, you place this entire function. Things will be cancelling out themselves simply. So you see this, yeah. Then on this function, so let me go back to this function where I solved it. So we have x plus h cubic. So let me just, for the sake of my brother and my sister, so let me do it from here. So x plus h cubic. So this is the same as x plus h multiplied by x plus h multiplied by x plus h. You multiply this function 3 times, so it's x times x will give you x cubic, again h times h. So you can do it on your own, because if I start doing this, it will take a lot of time. So you can just do it for practice. Progress to question number 2. So question 2 is saying find dy dx for each of the following functions. So you haven't been given whether it's a first principle or which you are using. So just note this one is the power law. So let's just go direct to the simple formula of a power law so that I explain it clearly. So suppose you have an equation where it's y is equal to ax to the power n, where n is the power and a is the constant. So to differentiate this function, you're just going to do, so dy over dx is equal to n to the power n minus 1. So this is what you how you differentiate a power using the power law. So now let's look at the questions now. So of the question, which is our question A is saying y is equal to x to the power 5 minus 3 over x squared plus 8x plus 1. So let's you can't solve this question directly. Okay, you can solve, but I don't advise solving it directly. So the best way you can solve this question is by rewriting it properly so that everything is one accord. So this will be y is equal to x to the power 5 minus. So this one, how do you write this one? So this means that it is 3x to the power negative 2. If the power is negative, the x squared comes down. Then plus 8x plus 1. So now to solve this question, you just have to use this principle individually. So in this one, you use this principle, this one, you use this principle, this one, you use this principle, and the for one, you use this principle to find the question. Now let's go direct to B now. So you finish up this one on your own for y over dx. So then for B, well, B we have been given to say 2x minus 4 over root of x. So if we write this one, you're going to have y is equal to 2x minus 4. Remember that root of x is the same as x to the power half. Now remember that we have 1 over, so this means this is negative. Then use this principle here to differentiate each one of these individually. Then now let's move to our C. Now before we answer question C, part C, so let's first do something very, very simple. So whenever you have been given natural logarithm, whenever you have been given y is equal to ln x, the derivative for ln x is just y complement. It will just give you 1 over x. So for now, this, how did we find this one? So the formula for this one, the formula is just simply dy over dx is equal to, so the differentiation of this, which is just d ln x over, so not ln, you just get x here over dx over, so you differentiate this x here over the overall function, which is x here. That's how you differentiate this one. So differentiation of x is 1 over x That's how you deal with these simple questions. Then when you have been given natural logarithm, okay, before we go to this is natural logarithm. Before we go to exponentials, from here, maybe we have been given ln 2x. How do you deal with ln 2x? For ln 2x, the answer will just be y prime will just be 2 over x. Then when you have been given ln, maybe let's say 3x to the power 2, the answer will just be, so for you to, for natural logs, you remember the certain principle. When you go to logs, there are laws of logarithm. You just say it will be 2 ln 3x. Then differentiating this one, you have two different answers. You have ln 3x, so you have ln 3x plus, now the derivative of 2, it's 0, so here you have a 0 multiplied by this. Then the derivative of ln 3x will just give you 2 here. Then so it will be 6 over x. That's how you differentiate this one here. Then bring it back now to be dy over dx will just be, so it will be 3x squared to the power, the derivative you have found. So this will be 0. So this will be 6 here. Then you have this x here. So it will be 6 over 3x cubic. That's how you differentiate this function here. Then when you go now to exponentials, whenever you have been given y is equal to exponential x, the derivative, the dy over dx is just dy over dx is equal to, so it will be d of x dx multiply dy, yeah, so dx exponent x. So this will just give you, differentiating x is just 1, so it will be exponents of x. That's why e to the power x is referred to be a special derivative, because each derivative is the still one. So that's why this one is very special. Whenever I've been given this function, it is a very special function. Now suppose we are given exponent y is equal to exponential x, let's say 2x. You just say y is equal to, you differentiate this, differentiation of 2x will just be a 2, so it will be 2 exponents 2x. That's how you deal with every question with exponentials. You just multiply the power here, you differentiate it, multiply it by the original function. That's how you deal with these simple things. Then now when you go now to trigonometry, whenever I've been taught to find d of sine x over dy, the answer will just give you cos x. So d of sine x over dy, the answer is cos x. Then differentiating cos x, so it will be d of cos x over dy. The answer will just be negative sine x. So for you, you just have to know this. You just have to know this. So this is dx, not dy. This you just have to know them. For business, you want to be told to prove them, but under NS and MSM 132, you will be told to prove how you do this. But under the school of business, you just go direct with it. Then for tan, I don't know for tan. Okay, for tan, let's just work on with tan. So whenever I've been given tan, so d of tan x over dx, the answer will just give you sec squared x. That's so. So for this one, you just have to know them directly. These are just the answers they always give you. Now, suppose you are given y is equal to cos, let's say 5x. Differentiating in this one, you just give you y prime is equal to cos. What's the derivative of cos? So the derivative of cos, it's negative sine 5x. Now this 5 will come here. That's how you differentiate this. Then for y is equal to sine, let's say 2x, the answer will just be y prime is 2 cos 2x. That's how you answer these questions. Now, having learned these three things, now you can now go on and answer part C of the tutorial sheet. So now take a look at part C now. So on part C we have y is equal to sine 5x. I've showed you how to differentiate every trigonometric function. So your 5x here, you know the answer. Even did I especially did this same one now. Just that I used cos, but that's the same thing I've done. Then in x, I've given you the answer for the in x already, minus root of 3. For root of 3, you already know how to do it. You can use this is just the power law. From the power rule, x to the power 3, you just know that this is, since it's a root, it will be root is the same as 1 over 2. So it's x to the power 3 in brackets to the power 1 over 2. That's how you deal with these questions. So for part 2, we are done. We have tackled all the three questions. So we have done the first principle, the power rule, trigonometric functions, exponential functions, and natural logarithm. So we're not just remaining with three rules of differentiation. Then you can do more questions on differentiation.